In this first section today, I'm just going to kind of reiterate the relationship between antiderivative and derivative. The antiderivative is what you would get if you took the derivative of this side, is what you should get here. So in the first couple problems tonight, all they're asking you to do is take a derivative of this side and confirm that you do get cosecant squared out of it. So just taking a look at our derivatives here, what is the derivative of a constant? Well, that's 0, so that's good because we don't have a constant over here. What is the derivative of cotangent? Well, we know that the derivative of cotangent is negative cosecant squared. So negative cosecant squared is positive cosecant squared u. So yes, the derivative of this side does equal to the integrand of this side. That's all an antiderivative is what derivative gets me this integrand. Let's look at another one. Here we say, okay, we have e to the 2x, and we know that the derivative of e to the 2x would be 2e to the 2x. So we're trying to figure out what the antiderivative is that got me e to the 2x. So I'm going to, again, take the derivative of this side with respect to x this time, because that's our variable. The derivative of a constant is 0. Derivative of e to the 2x, again, we said that was 2e to the 2x times that constant that we never really have to worry about in the terms of the derivative. And then 1/2 times 2, that's 1, so that's e to the 2x plus 0, which is e to the 2x. And we've confirmed that that antiderivative is correct. Let's look at one more like this, and it goes back to this idea of the derivative of inverse tangent or inverse sine, the inverse trig functions. So if I take a derivative of this side, I have to remember how I took the derivative of an inverse tangent or an inverse sine or inverse trig function to begin with. Well, let's say that y is equal to the inverse tangent of u. So I don't remember inverse tangent necessarily, but I do remember tangent. So if I took the tangent of both sides here, I'd have tangent of y equals u, because the tangent and inverse tangent would cancel out. Then I take a derivative of both sides. Well, the derivative of tangent y would be secant squared y, and the derivative of u would be u prime. But what is y? Or what is the secant squared of y, in other words? Now, it's very important here that we do recognize what we took the derivative in respect to, because it does matter. If I would have taken a respect with x, I would have a dy dx here, and this would be du dx. But since we really took a derivative with respect to u, we have a 1 here and a dy du over here. And since it's what we're really after is dy du, we can now solve for this and go dy du is equal to 1 over secant squared. Well, secant squared is already the reciprocal of cosine, so the reciprocal of the reciprocal is just the regular thing. So I have cosine squared of y. And since what this literally says here, uh, that the angle y has a tangent of u over 1, technically, because tangent is opposite over adjacent, we're looking at a right triangle setup, and maybe the y is this angle here. The opposite would be u. The adjacent would be 1. U over 1 is u. By Pythagorean's theorem, we can show that the hypotenuse here would be 1 plus u squared. And now we can actually find what the cosine of y is and square that and get our answer here. So dy du, cosine is 1 adjacent over hypotenuse, so we have 1 over the square root of 1 plus u squared. And since it's cosine squared, we have this thing squared, which, lo and behold, dy du is 1 over 1 plus u squared, which we knew that the derivative of inverse tangent was that. If you didn't, that would be something that you should want to look over for your quiz on Friday. Today, I'm having Mr. Bergdorf give you derivatives and antiderivatives or integrals that you should know for Friday's quiz. Very similar to what today's quiz looks like and may improve your score on today's quiz. But you should know these, learn to love them because they're going to make your lives a lot easier.